A Rogowski coil is a device for measuring AC electrical current. The coil is a helical winding of wire, resembling a large spring, with one end of the wire passed back through the center of the coil. When the coil is wrapped around a conductor through which current is flowing, voltage directly proportional to the current is induced in the coil. The AEMC, AmpFlex, and MiniFlex families of AC current probes incorporate Rogowski coils. Some of these probes include electronics to provide a stronger and linearized output signal. The diagram on the screen illustrates how these probes function. In this diagram, the probe's Rogowski coil has been placed around a conductor. As current flows through the conductor, it induces a voltage, called V1, within the coil. V1 varies in proportion to two values, the amount of current in the conductor and the AC frequency of the current. Calculating current from V1 requires the formula shown on the screen. In this formula, K is a value derived from the physical characteristics of the coil. These include loop size, the number of turns, and the length of the winding. dI over dt represents the change in current over time. This is dependent on the current's frequency. To convert V1 to a linear, frequency-independent output voltage called V2, the probe's electronics remove the time frequency variable from the equation. To do this, the electronics automatically adjust the gain in accordance with the current's frequency, using the formula shown on the screen. In this formula, Kf is a value derived from the physical characteristics of the coil for a given frequency. V2 can then be used to calculate the associated current by applying a frequency-independent scale factor, such as 1 millivolt equals 1 amp. For example, the probe can be connected to a digital multimeter or other measurement instrument to calculate and display the current reading based on the input voltage and scale factor. Rogowski coils offer several advantages over other probe types such as ion core, Hall effect, and flux gate. For example, they provide high resistance to electromagnetic interference, and there is no saturation when measuring high currents, ensuring the probes are subject to very little heating. They are lightweight and flexible. The probes can be wrapped multiple times around a conductor to amplify sensitivity, and they can be left unterminated without being damaged or developing hazardous voltage levels. The AEMC, AmpFlex, and MiniFlex families of AC current probes enable measurements on conductors where standard clamp-on probes cannot be used. AmpFlex and MiniFlex probes are lightweight and can be installed in tight places, around cable bundles, around wide or large bus bars, or even wrapped around irregular shapes. These probes create virtually no load on the system under test, have a low phase shift and excellent frequency response, and cannot be damaged by overloads. And they are insensitive to DC currents, so only the AC component of the measured signal is displayed. These probes produce a millivolt output proportional to the current measured for direct readings on digital multimeters, loggers, and power meters. Models specifically designed with a 1 MHz bandwidth are ideal for oscilloscopes, and the probes come in a variety of lengths. AmpFlex and MiniFlex probes can be used in a wide range of applications, including power measurements, measurements on switchboards and thyristors, switching measurements, and display of control signals. This concludes our brief review of how Rogowski coils function and the advantages they provide. For more information about AmpFlex and MiniFlex probes, visit the AEMC website, and be sure to check our YouTube channel for instructional videos about other topics in electronics.